So the third concentration term to be discussed is molality. It is represented by small m, whereas molarity was represented by capital M. So what is molality? Number of moles of solute per kilogram of solvent. Number of moles of solute present in 1 kilogram of solvent per kilogram of solvent. So M is equal to, M is molality, so this is number of moles of solute by mass of solvent in kilogram. N can be taken as WB by MB. Unit of molality is mole per kilogram. The question is molality a temperature dependent concentration term? So since there is no volume term involved here, so molality is temperature independent concentration term. Molality does not depend on temperature. Now, can we calculate the strength in terms of molality? Answer is no, because there is no involvement of volume here. Can we use dilution law here? Answer is no. Can we calculate resulting molality? Answer is no, because no volume term is involved over here. Now, the fourth concentration term is mole fraction, represented by a Greek alphabet chi, chi, but we can even call it as small x. It's okay. Now, what is mole fraction? It's a ratio of number of moles of a component to the total number of moles of all the components in the solution. Ratio. So, let us consider a solution of two components, component A and B. Please don't get confused that these are solute and solvent. These are simply component A and component B. So, the mole fraction of component A is number of moles for component A by total number of moles in the solution, which is Na plus Nb. Mole fraction for component B will be equal to number of moles of component B, which is Nb, by total number of moles, which is Na plus Nb. Now, if it had been a 3-component solution, then in that case we could have considered C, and mole fraction of C would have been equal to Nc by Na plus Nb plus Nc. But since it is a 2-component solution, so we have got A and B only. Now the summation of mole fraction of component A and that of component B is equal to 1. So this summation is equal to 1. So if in numerical we have calculated the mole fraction of component A, no need to go for this formula to do the calculation. Just subtract it by 1, you will get mole fraction of other component. So these are the two concentration terms, molality and mole fraction. Now let us work on concentration term for dilute solution. Concentration term for dilute solution. So this is the fifth one, concentration term for dilute solution. Concentration term for dilute solution. So it basically involves parts per million, ppm. So what is this parts per million? This is mass of solute by mass of solution, Wa plus Wb, multiplied by 10 to the power 6 million. So this formula could have been worked in terms of volume also, but we have considered here mass. Basically we will be getting numericals in terms of mass. So what does it means? For example, if a solution has got 15 ppm of CaCl3 chloroform by mass, it has been written in the question. So what does it stands for? This implies that 15 gram of solute chloroform is present in 1 million gram of solution. So what is the mass of solute here? Wb is equal to 15 gram. What is the mass of solution? In this case, mass of solution will always be equal to 1 million gram. So by what is the mass of solvent? So Wa is equal to mass of solution 10 to the power 6 minus mass of solute, which is equal to 15. So if we are subtracting 15 from a million, it is almost equal to 10 to the power 6 gram. So this is parts per million ppm. Likewise, we have parts per billion, ppb. This is equal to wb by wa plus wb multiplied by 10 to the power 9. Similarly, we have parts per 1000 ppt. This is equal to wb by wa plus wb multiplied by 10 to the power 3.